All right, so let's get started. Okay, hello everyone. My name is Mete Atamel. First of all, thanks for coming to my session. And today we're going to talk about containers, Kubernetes, and Google Cloud. This is going to be an intro-level session on why containers, why Kubernetes, and what does Kubernetes really do for your containerized applications. So before I start my talk, there's some information about myself. This is my Twitter. So I'm going to post the slides after my talk. So if you want the slides, just follow me on Twitter. And I also have my email. If you have any questions about any of the stuff I say today, you can reach out to me at any time. And after my talk, I'm going to go and be at the experts area. So if you have any questions, I'll be there as well. I also have a talk feedback link, bit.ly/my last name. So if you have any feedback about my talk, please leave them there as well. Also, today, I'm originally from Cyprus, and I live in London. But today I was walking to this event, and I don't know if you guys know, there's a website called 23andMe. Anyone knows what that is? It's basically like a genetic profiling site. So you sign up, and then they send you a kit, and you send your DNA, it's basically your saliva, and then they tell you where you are from. So as I was walking today, I was waiting for that result for like 2 months now. I got the results. And it said that I'm 75% from the areas around Cyprus, which is not surprising, but 25% I am from Sardinia. That's what I learned today. So I guess I'm 25% Italian in some way. So it's great. I think it was a great place to learn that today. So that was kind of exciting for me. Anyway, so let's think about software development. So when you think of software development, what does come to your mind first? What does it? Anyone? Anyone? DevOps. Okay. What else? Software development, is it fun? Yes, maybe. Not so much. Is it easy? Maybe. Well, for me, when I think of software development nowadays, I think of this. I think software development is really hard. The only people who really told me that it's not hard is usually product managers. They think that everything is possible and you should have done everything yesterday. But if you talk to software engineers, it's really hard. And the thing is, it's not getting any easier. You would think that with the passage of time, with the tools and cloud and everything, things would get easier, but that's not the case, at least in my experience. So anyone remembers these? Yeah? Some people? Okay. It's always good to have few people to remember these, so I'm not the oldest guy in the room. Basically, back in the day, I didn't use the bigger ones, but I used the smaller one, the one in the middle. Back in the day, you would have your MS-DOS. You would put in your floppy drive, you would close it, you would turn your computer on, it will load the operating system in like a minute or two, and then you would get the A prompt, and then from then on, you would take the operating system out, you will put the basic, I think I used QBasic or GW Basic when I first started programming, and then you would just get into basic and start coding, right? And the thing is, there was no internet, there was nothing, so this was literally the only thing I had to worry about. When you think of microservices, there's this notion of bounded context. Well, back then, the context was this disk, and it was like physical, so you could see it, you could feel it, and life was really easy, I remember all I had was this disk, and then I had a book on basic, and I would just look at my book, do some stuff, look at my book, do some stuff. At some point it was hard because there was no Stack Overflow, so if you're stuck, there's no one to ask help for. But I like the simplicity of those times because all I had to worry about was just, I have a problem and I want to solve that problem. Since then, a lot of things changed. The first thing is obviously internet. And then after the internet, we had all these things that happened. So we had like object-oriented programming, virtual machines, cloud computing, caching, machine learning. So it's really impossible to stay on top of all of this, right? So what I try to do as a software engineer is I pick and choose what I like and try to learn as much as I can. For example, microservices is one thing that I really like, so I try to learn as much as I can. And I'm trying to learn about machine learning because that's where the programming is going to evolve into. But then I also try to get an overview of the rest of the landscape so I know what the landscape is all about, right? But it is impossible to learn and know everything nowadays. So nowadays, if you have a problem, what you do is you start with the code again. So you write your code. So let's assume that this is the piece of code that you wrote to solve a problem. It's not on the disk anymore. It's usually hosted on some kind of server. So you find a server somewhere and host your code. it can be your server maybe, or maybe it's some cloud provider server, so it doesn't matter. Your code runs on a server somewhere, right? And then someone says, what happens if that server goes down? What do you do? So you have to have redundancy. So what you do is you basically add a number of servers. It depends how many you want, but usually 2, 3 is enough. And then you run the same code on those machines. But then the clients, they need to know the IPs of those machines. That's not ideal. So what you do is you create a load balancer that has a stable virtual IP, and then the clients will talk to the load balancer, and it will get to the machines as it needs to, right? So all of a sudden, you have like your code, your machines, and your load balancer. But then how do you know your machines are actually healthy? So to do that, what you usually do is you create what's called a health endpoint, and that will check what it means for your application to be healthy. And then if it's healthy, it will say okay. If it's not healthy, it will say not okay. But someone has to actually check these health endpoints, right? So what you have is usually a health checker that will ping these endpoints and check whether that machine is healthy or not. And if it's not healthy, you probably want to create a new machine and add your code there as well. So this is great for one zone. Everything lives in one zone, but you are relying on a single zone. And as we know, even in the cloud, sometimes zones go down. So what do? You create the whole setup in a different zone with the same load balancers, same machines, same health checking and everything. So this is good, so I have redundancy, but then how do I keep the two in sync, right? So that's another problem. So what you usually do is you have something in the middle. You either have like a master or slave, or you have some kind of task queue in the middle where the state from one zone gets replicated to the other state. So that way they're in sync, right? So that's great. I have 2 zones, they're replicated and everything's good, but what if my application is getting really popular and I need to scale up, right? You can scale up manually as you need to, but it's difficult because usually applications, they have cyclic graphs, so people use them a lot during the day, but at night they don't use them as much. So you usually scale up during the day and you scale down during the night. So no one wants to do that manually. So what you usually do is you create an autoscaler that will look at your load somehow and figure out how to scale up and down, right? So this is how it looks like nowadays, and it gets much more complicated than this, but this is kind of like the basic scenario that you need to implement usually. And this is for running a piece of code on a single type of machine. If you need to run different types of applications in different languages on different kinds of machines, then you have more work to do. If you want to deploy a new version of your application, then you need to worry about this whole machines and zones and stuff like that. So it's not so easy to deploy your new version anymore. If there's something wrong with that new version and you need to roll back to the previous version, you need to do that in a consistent and stable way. If you want to do configuration and secrets of your application, you need to manage them somehow. You need to make sure that they're centrally managed, and you need to somehow get them working with all the machines in certain way. And if you need to do scripts, because usually when the machines come up, they usually have some kind of scripts to run. So that's not the code, but it's actually things that make your application work, so you need to manage those scripts as well. So there's all sorts of things that you need to worry about right now. So if you're like me, you're probably feeling like this guy right now. You know, you just want to write some code to solve some problem, but now all of a sudden you have to deal with all these problems. So the reality of today is kind of like this. You want to care about the code that you're writing. That's what you're trying to do. But then in reality, this is all you're trying to do. You're trying to create all this infrastructure so that your code runs in a consistent, stable, and a resilient way, basically, right? And actually, in one place that I worked before, this ratio of coding versus operations got so bad for me that I was spending 90% of my time trying to manage all of this rather than writing the code. So this balance has to be really, really maintained properly. So what do we do? Well, in the good old days, up until recently, what we used to do is that first we write our code, and then we pass that code to QA for testing, because as software engineers, we don't test our code, right? That's someone else's job. So we'll pass it to QA and say, just go ahead and test this code. They will find some bugs, send them to us. We'll fight back and forth whether they are bugs or not. Eventually, we'll fix the bugs, and if the QA person is happy, then we'll pass it to operations people and let them deal with it in production, let them run it. Because as software engineers, we don't have to worry about running code in production. We can just let someone else worry about that, right? So we took this like hands-off approach, basically, where we just write our code and just give it to people for testing and give it to people to run, and it's not really our problem. Well, this didn't really work, so that's why we have DevOps. So I'm sure most of you know what DevOps is, but in DevOps, basically the idea is that you write your code, you test your code, you run your code, and if there's something broken, you fix it, and you basically have the full life cycle of your code. There are good things and bad things about DevOps. The good thing is that you have that feedback loop that you need as a software engineer to write really good code, because you have an incentive not to wake up in the middle of the night. So you make sure that your code is resilient, and it actually works. I've seen that work. But then with DevOps, you need to make sure that you have the tools and the resources and the structure that you need to do it right. So I've seen some places where they just think that they're doing DevOps, but what they're doing is actually they're just deploying code as fast as possible and let that code burn in production, and then with that, the whole development team burns as well because they're spending so much time trying to fix things in production rather than writing the code. So what do we do then? So if I have to imagine how software development should be, I think there are three things that I want to be true. The first thing is that I want, as a software engineer, I want to write code in any language I want, and I want that code to run exactly the same way everywhere, right? Because I don't want to be constrained by certain languages, and when I run my code on my laptop, I want to make sure that it exactly runs the same way in the cloud as well. I want this to be true. The second thing is that I want my code to be optimally deployed somewhere and managed by someone, but I shouldn't really worry about that myself, because I'm solving problems, I'm thinking about business problems. I don't necessarily need to figure out every single time where should I put this code, or is this server the right place to put it. Someone has to do that for me. I mean, you would think that at this point in software development, we'll get to the point where this is done for us, right? And the third thing is that I don't even want to think about machines. You know, like I want to think about problems and solving those problems with code. I want machines to be available to me when I need them. I want them to scale up when they need to. I want them to scale down as they need to. If I need some kind of data store, I want that to be available to me. I shouldn't worry about machines, provisioning machines, all that kind of stuff. So this is what I want. And if you look at the last few years in the industry, we are actually moving in this direction. So when we think about writing your code in any language and running it anywhere, that's basically what containers are all about. So Docker and Rocket, they're basically trying to create this context for your applications where the context really transfers from your laptop to your cloud, and your application runs in that context in a consistent way. When we think about your app being optimally deployed and managed, that's the whole point of container management platforms like Kubernetes and Mesos and Docker Swarm and things like that. So all they are trying to do is run your containers in a consistent way anywhere. And the third thing about all the resources being available when you need them, well, that's what the cloud is all about, right? So Google Cloud and other cloud providers, they're all trying to make it so that the resources that you need is available when you need them. So we are going in the right direction, and we have tools and clouds to do the job. So we'll take a look at Kubernetes today and see how that provides what we need. All right? So now what I'm going to do is, first I want to build a really simple Hello World service, and I'm going to do that in Google Cloud. And then later we'll take this service and we'll containerize it using Docker and see how that looks like. And once it's containerized, we'll take the container image, push it to Google Cloud so that we can use it in other places. And then we're going to create a Kubernetes cluster, and we'll use that container in Kubernetes cluster. So through that, we'll learn what Kubernetes is all about. So first, let's look at our microservice. And for this, I'm using an ASP.NET Core application. So are there any .NET developers here? No? OK. Well, .NET used to run on Windows and nowhere else, but recently ASP.NET Core came along, and it's basically a multi-platform version of .NET that runs on Windows, Linux, and Mac. And I'm really impressed by the fact that .NET runs on Linux, so I'm using that in my demos. So we'll use that application as a starting point for our microservice, but you can use any kind of application here. It's really, the language doesn't really matter. So here I am in Google Cloud Console. This is the main console to manage our projects in Google Cloud. I activate Cloud Shell. This gives you a development environment in the cloud. So by clicking there, I'm basically getting a Linux box somewhere in the cloud, and I also have a home page where I can create my application. So I'm in the browser, and I can access to my Linux box. So what I'm going to do is I'm going to first, so if I just type .NET, that's the command line tool to create .NET applications. It's already installed in Cloud Shell, so I don't have to worry about that, installing that. What I'm going to do is I'm going to create a folder for my application. I'm going to call it Hello World ASP.NET Core. And then once I have that folder, I'm going to use the .NET command line tool to create a Hello World application. So what I'm going to do is I'm going to say .NET new -t web. So this creates a web Hello World application. And if you look at the files, there's a lot of files that are created for us. Program.js is the main entry point to my application. So I'm going to edit that file, and I'm going to add a single line to that program.js to make sure that my application binds to port 8080, because I want to be able to test this application from the browser. So to do that, I want to make sure that it starts on port 8080. So I'm adding one line that says use URLs and HTTP star 8080. This way, my application, when it starts up, it starts on port 8080. So I go back. The first thing that I need to do is .NET restore. So this basically looks like the project.json file. This is the file that determines the dependencies of my application. It will find the dependencies, and it will download them from NuGet. NuGet is the dependency management platform of .NET. So we'll go to NuGet, restore the dependencies so that I have all the dependencies here. Once I have that, I can do .NET run, and this will run the application on the Linux box, and then we will preview it, make sure that it works. And once it works, we can containerize it. So I'm doing .NET run. So this will compile the application on Linux, and then it will run it on port 8080. So once we see the prompt that it's running on port 8080, we know that the application is working. And there's a nice feature of Cloud Shell web preview. So if I click that, it will find the Linux box that I'm running, and it will bind to port 8080 automatically, so I don't have to worry about the IPs and stuff like that. So now my app is running on Linux. Good. So nothing fancy, but we'll use this as a reference app to containerize and move on. All right, so we got our app. Next step is containers. I mean, why should we even bother with containers? So let's try to answer that question first. If you look at what we used to do up until recently, we used to do something like this. We would have a physical machine. We would install the kernel, the operating system on the machine, and then we will install all the tools and libraries that we need for our applications, and then we'll deploy our applications on top of that, right? The good thing about this is that there was a single machine, single operating system, single set of libraries, so it was easy. But then the bad thing is that the applications, they don't have any isolation whatsoever from each other. So if you change something in the operating system, or if you change something in the libraries, you could potentially break any of these applications. So it was easy to do, but very easy to break as well. Then we had virtual machines. The idea with virtual machines is that you have a single physical machine, but then you virtualize the operating system and the libraries of your application. So you put them in a virtual machine. The good thing here is that applications are totally separate from each other, so they are totally isolated. So if you change something in one place, it's not going to affect the other place. But the bad thing is that you have 4 operating systems and 4 set of libraries that you need to worry about. So this is a lot of management overhead. So what happened is that people used virtual machines in production, but they didn't really use them as they developed their applications because it was a pain to do, to manage all of this stuff from your laptop. So it was more like a deployment time kind of thing, the virtual machines. So with containers, you kind of have best of both worlds. So in containers, you have a single physical machine and a single operating system, but you're virtualizing from libraries up. So your application and its dependencies, you're virtualizing them in what's called a container. And these containers, they're much smaller than virtual machines, so they're much more lightweight. So this way, it's simple because it's one machine, one operating system, but it's isolated as well at the same time. So it's combining the best of both worlds. So what is a container? As I mentioned, it's a lightweight way of virtualizing your applications. They're sealed and isolated, so you can have multiple containers on a single operating system, and they don't interfere with each other. They're easy to deploy. So compared to virtual machines, you can deploy stuff to a container in seconds. They're easy to introspect, so you can actually SSH into the container, look what's running, you can look at the logs, all that kind of stuff. And for me, the most important part is composable. They're easy to compose. So what you can have is that there's a base image that you depend on, and then you can build your image and your application in a separate image that depends on the base image. And if people need to depend on your application, they can build an image on top of your image. So this way, you can layer your dependencies And this is very important because that way, if someone depends on you, all they have to do is get your image and build on top of that. So that's nice. Oh, I should also mention Docker is the main container platform that most people use, but there are others like Rocket from CoreOS, and I'm sure there will be more going forward. And also containers, they might look like they're something new because we started talking about them in the last 2-3 years. But at Google, we've been running containers for a long time, for more than 12 years. Everything in Google, Gmail, search, even the virtual machines within Google Cloud Platform, they run within containers because we like the security model of containers, and our whole infrastructure is optimized for containers. And actually, we launch more than 2 billion containers per week, so you can see the scale of containers at Google. So now let's take our simple application and try to containerize it and see how that looks like. So here I am in Cloud Shell again. I have my application. First, what I need to do is I need to put all my application and its dependencies into a single DLL. So this is a single package for my application basically that I'm going to build. To do that, I run .NET publish-c release. So this will compile my application. It will compile all of its dependencies, and it will create a single DLL. Later, I'm going to use this DLL from Docker. So Docker will call this DLL. So that's why I'm doing this. As this is building, next step will be to build what's called a Docker file. A Docker file is basically a blueprint for an image. So it basically tells Docker how to build your image. So we'll create a Docker file, and we'll take a look at the Docker file because it's very important to see what's in there. So we built our DLL, and next we're going to copy a Docker file that I created into the release folder, and we'll take a look at that. So DLL is built, and let's just go to the release folder where my DLLs are. I'll just double check that everything is there. Yes, I have my DLLs. I only need the one that I just built, actually. So what I'm going to do right now is I'm copying the Docker file that I already created to here, and now we're going to take a look at that file because it's very important. So let's just pause here for a second. So this Docker file, the first line says, from Microsoft.NET 101 runtime. So this is the image that I depend on. So this is an ASP.NET Core application, and it depends on an image provided by Microsoft called .NET 101 runtime. So this is the runtime image that I depend on. The second line says copy.app. So it says copy everything in this folder, the DLLs, to the app folder in the container. Then the third line says the working directory app. So the app folder in the container will be the working directory. And then expose 880. So this will expose the port 880 in the container. And then the other one is an environment variable. So this is ASP.NET Core URLs. So I am basically setting an environment variable to make sure that my application starts on port 880. And the last line is entry point. So what happens when the container starts? So here I'm calling .NET. This is the command line tool to run .NET applications. And I'm pointing to the DLL that I just built. So if you think about it, the first line is my dependency. The second through the last line is my environment that I'm setting. And the last line is what happens when the container starts. So with one file, I'm basically defining my dependencies, my environment, and what happens when the container starts. This is great because without this, you have to basically tell people, install this, install that, set this environment this way. So you have to give all these instructions and make sure that they follow it properly. But with Docker, you don't have to do that. You can just specify what you want it to be true, and it makes it happen. So that's great. So this is the Docker file. So what we're going to do is we're going to now build an image from this Docker file. So the image will basically look at this, this Docker file, and it will build an image that we can use. So to do that, we use Docker command line tool. It's already installed in Cloud Shell, so you don't have to install it yourself. So I'm saying Docker build -t means tag my image. So I'm tagging it with some data. So gcr.io refers for Google Container Repository, because I'm going to push this image to Google Cloud Container Repository later. And then hello.net is the name of my image, and v1 is the version of my image. So it's basically looking at the Docker file, and it's going through the steps. The first step is my dependency, what I depend on. And it's an image from Microsoft. I don't have it, so we are downloading that from Docker Hub, basically. So it's getting the image from Docker Hub, and it will save it to local Linux box. So we're getting the image, and then once we have that image, we'll go through the other steps. We'll set up our, we'll copy files, and we'll set up our port, and all that kind of stuff. So we'll let that happen. So the image is built. So if we actually do Docker images, we should see both our image and our dependency image. So if you do Docker images, the first one is my image, and the second one is the image that I depend on. So they're both on this machine. Now I want to run this image, make sure that it works. So to do that, I'll do Docker run. -D means run in the background, and then -P means port. So I'm mapping port 880 on my machine to port 880 in the container, and I'm just pointing to my image that I just built. So this basically runs the image locally. And once this is done, I get a hash code that tells me it's running. If I do Docker PS, I see that it's running. And then if I do web preview, I should see the same application. But the difference in this case is that this application is running within Docker container, basically. So there you go, the image is running. So the next thing that we're going to do is, once I have the image, I'm going to push that image to Google Cloud. So I'll do Docker stop to stop my application. And then I'll do gcloud docker push. So this way, I'm basically taking the image that I just built locally, and I'm going to push it to Google Container Repository. All right. So we'll fast forward this, because we don't have that much time. But then what you will see is that basically at the end of this, the image will be pushed, and we'll be able to use this image from Google Cloud. So let's just get out of here. So containers are good, because now I have an image that I can push it to anywhere and use it from anywhere, so it gives me the context I need. But then to run this in production, there are still questions that you need to answer. For example, if you want to have redundant services, you need to run multiple copies of these containers. So you need to do that yourself. If you want resiliency, you need to create an endpoint. If you want to scale up and down, you need to do that yourself. So all this stuff that you need to do in production, you still need to do that. Docker or containers, they don't really help for that. So that's when Kubernetes comes in. So Kubernetes, it's a Greek word, and it stands for governor. Actually, the right way of saying Kubernetes is Kubernetes. But I guess it started in the US, and everyone calls it wrong. But if you don't learn anything in this talk, just learn that it's called Kubernetes. Basically, it's a container management platform. It's 100% open source, written in Go. It's supported by companies like Google, IBM, and many other big companies. The greatest thing about Kubernetes for me is that it runs on multiple cloud providers. So you can have a Kubernetes cluster that runs on AWS, that can run on Google Cloud. And you can even have a single Kubernetes cluster that spans multiple cloud providers. So that's the great thing about it. It came from something called Borg, which is an internal container management platform that we use at Google. So people who worked on Borg, they basically learned from that over the years, and they created Kubernetes for everyone else. So at the high level, this is how it looks like. So you have a master that has multiple things like API servers and etcts and schedulers and controllers. And then you have nodes where you actually schedule containers. They talk through something called kubelets, and then as a user, you talk to the master either through API, CLI, or UI. So at the high level, if you want to use Kubernetes in Google Cloud, you would basically build an image through a Docker file. You push that image to Google Container Registry. We just did that. And then from there, first you need to create a Kubernetes cluster. So you use gcloud to create a Kubernetes cluster. And then from then on, you use kubectl, which is the command line tool to manage Kubernetes, to schedule your images to a Kubernetes cluster. So now let's take a look at how to create a Kubernetes cluster in Google Cloud. So first, as you see, I push my image, and if I go to Google console and go to container registry, I should see my image already in Google Cloud. So I go here, there's hello.net, and then there's different versions, but the version 1 is the one that I pushed. So now my image lives in the cloud, and I can use it in many different places. One of those is Kubernetes. So what I'm going to do is I'm going to use gcloud again to create the cluster. So I'll say gcloud container clusters create. And this will create a Kubernetes cluster for me. I'll give it a name, so I'll call it hello.net cluster. And then I'm going to specify how many nodes I want to schedule my containers. So number of nodes is 1, and then machine types is standard. So there are different machine types in Google Cloud that you can use, but I'm using standard machine types here. And then I also want to make sure that this cluster lives in Europe West. So for zone, I'm saying Europe West. So with this one line of gcloud command, I will get a cluster with a master and with a single node where I can schedule containers, and I can use that to schedule my containers. So if you go to container engine, I should see at some point a cluster comes up. So let's just fast forward. And at some point, I'll see a cluster coming up, and then from then on, I can use the cluster. So it's just one command, basically. All right, in the last 10 minutes, I'm going to cover what Kubernetes is. So Kubernetes, it comes with a lot of building blocks. So this is some of them, and there's even more. We won't have time to cover them all, but feel free to stop by so I can tell you more about them. But at the high level, this is how Kubernetes cluster looks like. You have your container. From your container, you create what's called a pod, which is either a single container or multiple containers, depending on what you want to do. Then after that, you create something called replication controller. So in replication controller, you basically tell Kubernetes what you want it to be true. Here, I'm saying replicas 3, so I want 3 copies of this pod. Then Kubernetes will look at that and say, OK, I need to create 3 pods. It creates 3 pods, and it schedules them onto some nodes. But that's something you don't have to care about. Like Kubernetes figures out where to schedule these nodes. And then once these pods are running, you can expose them to the outside world using what's called a service. So service is kind of like a load balancer for your pods. So the first thing that I want to talk about is deployment. So in Kubernetes, when you start, you create what's called a deployment. It's basically a high-level construct that you create. And under the covers, it creates all the lower-level things that's needed to run your containers. So it creates pods, it creates replica sets, and it creates services for you. And we'll look at what those are shortly. So let's just take a look at how to create a deployment. So here I am. My cluster is ready. And then I want to basically schedule my first container to Kubernetes. First, to do that, I need to use kubectl, but I need to authenticate this shell with Kubernetes cluster. So to do that, I just run a command. So once I run this command, my shell is authenticated with Kubernetes. And now I can use kubectl to manage my Kubernetes cluster. So I'll say kubectl run, and I'll give my deployment a name. So this is called hello.net. And then I'll just point to an image. So I push this image from my machine to Google Cloud. So now, since it's in Google Cloud, I can easily refer to that using image. And that's it. So I just refer to my image. And then I also want to make sure that the port 8080 is enabled. So I'll say port 8080. And then with this, we basically created a deployment in Kubernetes. So it's just one command line. So if you do kubectl get deployment, I should see that my deployment is ready. It's very fast. And if I do kubectl get pods, you will see that I have some pods being created. So it's a status container creating. So it's creating the container, and it's trying to schedule it. If I do get pods again, I should see the status running. So within a few seconds, the container is created and scheduled. So that's great. And then there's also a replica set that's being created that we'll talk about. And then there's also a service that's been created. And if you look at the service, there's an internal IP, cluster IP, but there's no external IP because I haven't exposed this pod to the outside world yet. We'll do that next. So as you see, all the stuff that I need is created. So let's just briefly look at what the rest of the stuff is. So pods, volumes, and labels. So let's just talk about them briefly. So a pod is basically the smallest scheduling unit in Kubernetes. Usually, you have a single container in a pod. But sometimes there are cases where you have multiple containers in a pod. For example, in this case, I have a container called file puller that pulls some files from some content manager, and then it saves it to a volume. And then there's another container called web server that serves from the volume to the consumers. So I want these 2 containers and their storage, that's called volume, to live in a single unit. So that's what a pod is. A pod basically just puts them all together, and Kubernetes will schedule that together, and it will kill them together, basically. And a volume, as I mentioned, it's basically storage for the pods. And you can attach a volume to many different things, like a persistent disk or something like that. So once you have your pods, you can label them. Labeling is the way you group things together in Kubernetes. So once you attach labels to your pods, you can use selectors to get your pods. So you can say, give me all the pods of my application using this way. Or if you want to get all your pods of the front end, you can say this way, and stuff like that. So once you have your pods, then you can use something called replica set. Replica set is the favorite part of Kubernetes. So you can think of replica set as a big brother watching your pods. So you tell replica set what you want it to be true, and it makes sure that what you want is maintained at all times. For example, in this case, The number of replicas is 3, and then there's some selectors I'm using. App equals demo, and color is blue or gray. So I'm telling replica set, make sure you have 3 pods at all times with these labels. And then it will maintain those pods on some nodes that I don't care about. And if any of these nodes pods go down, it will create a new pod and schedule it on the node. So it will make sure that this is always true. So I have a replica set. Let me just show you this quickly, and this is probably going to be the last demo. So here I have my pods running. So what I'm going to do is I'm going to delete this pod and see what happens. So I'm going to say kubectl delete, and then pass in the pod ID. So what happens right now is replica set is watching my pod, so it will detect right away that the pod is deleted, and it will create a new one. So if I do the delete, then if I do get pods again, you'll see that a new pod with a new ID has already been created. It says status container creating. So replica set watches basically your pod, and as soon as it's deleted or something, it will create a new one and schedule it within seconds, which is good because I don't have to do that myself. All right, and then so you have your pods, you have your labels, and then you have your replica set watching your pods. Now you're ready to expose your pods to the outside world. So you will do that through what's called services. So the idea of service is that you basically use a selector to select the pods that you want to expose. In this case, I am selecting all the pods that have type equals FE. So all the pods that have that label will be exposed behind the service, and the service will have a stable virtual IP, and the clients will talk to the service to get to the pods. So to actually expose our pod, it's again one line of code, command. So I have my deployment running, I have my pods running, and if I want to expose this pod, all I have to say is kubectl expose deployment, pass in my deployment ID, which is hello.net, and then I'll say type equals load balancer. So this will basically create a load balancer in Google Cloud. It will attach that to our Kubernetes cluster. And once the load balancer has an IP, we can hit that IP, and it will go through the service, and it will get to the pod. So here, if I do kubectl get service, we'll see that the external IP is pending, because it's creating a load balancer right now. And I will fast forward, because we don't have that much time. At some point, when I do kubectl get service, I will have an external IP. Maybe not here, further down. Yeah, now I have the external IP. So what this means is that if I hit that IP, I will hit the load balancer, and that will route me to the right pod. So this is the same code running, but it's running within Docker container, and it's being managed by Kubernetes. So Kubernetes watches that container for us. All right, I only have 2 minutes, so that means I have to speak really fast in the last 2 minutes. But what I want to tell you is, so scaling in Kubernetes becomes really easy. So if you have 3 pods, to scale to 4 pods, all you have to do is just tell replica set you want 4 pods, and it will just do it automatically, just one line of code, very easy. You can set auto-scaling, so you have your pods. You can deploy something called Heapster, which is a really cool name, that will collect all the CPU metrics, if that's what you want, and it will report to replica set, and replica set will look at its rules, and it will determine if the CPU target is more than 50%, create a new pod, and auto-scale. And I have a demo, but I have to skip. Then you can do canary deployments, so you can have 2 replica sets with 2 different kind of versions, but you can expose them behind the same service and do canary deployments. And then you can do rolling updates. So let's say you have a version 1 of your application, and you want to do an update to the version 2. You create a new replica set with version 2, and then add a new pod to that, and you expose everything behind the same service. And then if everything looks good, you take one out here, you add one here, you take one out there, you add one here, you take one out there, and if everything works, you get rid of the replica sets. So to do this in Kubernetes, it's again one command. You just say update, do a rolling update, and it does all of this for you automatically. So I have an demo, but I can't show that to you because we don't have time. But feel free to stop by after the talk. And then there's other stuff. There's daemon sets, there's jobs, there's config maps and secrets, but we won't cover them here. Just know that they exist. So there's lots of constructs, basically, that makes your life easier when you want to run containers in production. There's even more. I didn't put it here. But if you want to learn more, Kubernetes.io is the page to go. If you want to learn about Container Engine, cloud.google.com/container engine. And if you want to get the slides, follow me on Twitter. And if you have any questions, I'm going to be outside at the experts area. Thanks a lot for listening.